Hello, so in today's video, we're going to look at summing terms in an arithmetic sequence. So just to motivate what we're going to do in this video, so consider an arithmetic sequence like this one here. So 2, 5, 8, 11, 14. So let's consider this arithmetic sequence. First of all, it is an arithmetic sequence because each time we're adding 3. So this is definitely a linear sequence. This is definitely an arithmetic sequence because remember, linear and arithmetic sequences are exactly the same thing. So it's definitely an arithmetic sequence. So let's say you get a question which says, what is the sum of the first 100 terms of the sequence? So let's say you want to do 2 plus 5 plus 8 plus 11 plus 14 and so on up to your 100th number. How could you work that out? And is there a quick way or a quick formula we could use to actually work that sum out? And the answer is yes, there actually is. So yes, there is a formula. So what I've said here, so we're going to let AR, so A1, A2, let me just make this clear here. So we've got a sequence of numbers A1, A2, A3, A4. So we're going to let this be an arithmetic sequence of numbers. We've got an arithmetic sequence here of numbers. We're going to let A, so A is going to be our first term. So actually, we'll just call this first term here. We'll call that A. So A is our first term. And our common difference is going to be D. So each time we're going to add D to get the next number in the sequence. So we've got something like this going on. Then the fact that we need to know is that when we sum the first n numbers in the sequence, remember this sigma notation, this sum notation. So when we sum the first, so going from r equals 1, so A1 up to an, so when we sum the first n numbers in our sequence, the formula is this. So n over 2 times 2a plus n minus 1 times d. That is the sum of the first n terms of an arithmetic sequence. That's the formula, and it will be in your formula book, that formula there. So you don't have to learn it, but obviously you need to know what the letters mean in that formula. So let's just make this clear, that this summation is the sum of your first term plus your second term plus your third term plus all the way up to your nth term. So A1 plus A2 plus A3 plus dot, 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 up to AN. So the sum of those numbers is given by that formula there if this is an arithmetic sequence, and this only works if it's an arithmetic sequence. So let's go and see how we can prove the formula then. So we want to prove that the sum of the first terms, the first n terms in an arithmetic sequence is this formula there. So we've got the sequence, so we've got the first term, which is A, we call the first term A, and then the next term is going to be A plus D, because remember, we've got a common difference of D. So each time to get to the next number in the sequence, we're adding D. So adding D each time, D each time. And the same thing over here as well. So our second last term is going to be this here, and our last term is going to be A plus n minus 1 times D. So the reason for that is because, yeah, this is our first term. A is our first term. There's no D's involved in our first term. But in our second term, there's 1D. In our third term, there's 2Ds. So in our fourth term, there's going to be 3Ds. In our fifth term, there's going to be 5Ds. So in our nth term, there's going to be n minus 1Ds. So that's why we've got an n minus 1 next to the D rather than just an n there. Okay, so we've got that sequence there. Now let's think about how we could add up these numbers. So we're going to sum, again, use the sum notation. So we're going to sum the first n numbers in our sequence, and I'm going to call this capital SN again. So again, this notation here, capital SN, just means the sum of the first n numbers in a sequence. So we've got A plus D plus A plus 2D plus A plus 3D plus A plus 4D, all the way up to A plus n minus 1D. So what I've done here is I've just rewritten the order. So I've swapped the order around. So I put the biggest number first, well, the last number first, and then the second last number there. And then basically we're going to add up, add backwards basically. So I mean, if I write it more explicitly like this, so we're going to add up, so I'm going to actually just move my writing across to there. So we're going to add A plus D, and then lastly A. So I've just swapped the order. I've instead of writing the sum in ascending order, here I've written the same sum, exactly the same thing, but in descending order. So backwards instead this time. Okay, so now 2SN, so double the sum, is when we add both of those sums together. So SN plus, let me again just move this word across there. So this sum plus the exact same sum down here, what happens when we add those together? So again, similar to when we proved the sum of the first n terms, n positive whole numbers in in one of my previous videos. It's exactly the same kind of idea. We're going to add together these terms here. So a plus n minus 1d, that's going to give us a 2a plus n minus 1d. Likewise with this over here, when we do this summation here, we've got a plus d plus a plus n minus 2d. A plus a is going to give us a 2a. And then d plus n minus 2d, well, d plus minus 2d, that's going to give us a minus d. And then minus d plus nd, that's going to give us an n minus 1d again. And actually the same thing happens again and again and again. We always get the same result. So there's 2a plus n minus 1 times d. And when we get up to our last one here, so let's just do this last one here explicitly. So when we add those at the end there, a plus a will give us 2a, and then n minus 1 times d is just n minus 1 times d. So that's going to be our last part there. So we're adding this we're adding this 2a plus n minus 1d, basically n times, because remember, we've got n numbers in our sequence. So we've got n terms, so n numbers in our sum. So n numbers in our sum. So we're adding the same number n times. So this is the same as adding 2a plus n minus 1d n times. So when you add something n times, it's just the same as multiplying that number by n. So actually the result is going to be n times by 2a plus n minus 1d. But that's double the sum. So remember, this is 2 times the sum we wanted. We wanted to calculate Sn. That's the sum we actually want to prove. But that's actually going to be double the sum. Let me just try and make the writing smaller. There we go. And I'm just going to move it there. So therefore, we know that 2 times the sum we want, so 2 times Sn equals n times by 2a plus n minus 1d. So therefore, divide both sides by 2. We get the sum of the first n terms of our arithmetic sequence is going to be n over 2, divide both sides by 2, and then times by this 2a plus n minus 1d, and that is the result proved. So we now prove that the sum of the first n terms of an arithmetic sequence is given by that formula there. Okay, so now let's go back to our example. So we've got 2, 5, 8, 11, 14. How do we sum the first 100 numbers of the sequence? Well, we're going to use the formula. So the formula that we just proved, exactly the same formula here. So n over 2 times by 2a plus n minus 1d. So we want to sum the first 100 terms. So our n value here is going to be 100. Let's just make a note of this. So we're summing the first 100 terms. So instead of summing the first n terms, we're summing the first 100 terms. So n is going to be equal to 100. Our a value is always our first number in the sequence. So if we look at our sequence here, our first number is 2. And then our difference, what's our common difference? So we're adding 3 each time, aren't we? So we're going to add 3 each time. Add 3 and add 3. So therefore, our common difference, d, is 3. So if we just plug those numbers into the formula, we will get our sum. So it's going to be 100 divided by 2 times by 2 times a, which is 2, plus n, which is 100, take away 1, which is 99. So 99 times by d, the difference, which is 3 there. So we're going to get 50, because 100 divided by 2 is 50, times by 4 plus 99 times 3. I think that's 297. So 297. So we got 297 plus 4. That's going to give us 301. So we get 50 times by 301. And so we get a final answer of 15,000, 15,050. So the sum of the first 100 numbers in this sequence is actually going to be 15,050 using using this fact here that the sum of the first n numbers is n over 2 times 2a plus n minus 1d. So yeah, we can just use that formula to work out these sums. And also you do need to know how you prove this result here. And that is how we would prove it. So we add the same series together, the same sum together, just in ascending order and descending order. We combine the biggest with the smallest, the second biggest with the second smallest, the third biggest with the third smallest, so on and so on and so on. We get this result here. We're adding this up n times and then divide by 2 at the end to get our final result. So that's how we can prove that formula there.